Hi, so welcome to my talk for Kubernetes Community Days Pakistan on the topic of deployments versus stateful sets versus daemon sets. My name is Mohammad Ali Kahoot. I'm currently working as a senior SRE at pawaPay, a Europe-based fintech. I'm working remotely from Pakistan. I am also a DevOps consultant at Dalil. Uh, I was previously working as senior DevOps engineer at Tarabut Gateway and have also led the team at Stacator Aurora Solutions. I'm currently working as a part-time DevOps trainer at Dice Analytics as well. I graduated from FAST in Bachelor's of Computer Science and working with Kubernetes since 2016. I have a blog on Kubernetes on the same topic, which has received quite appreciation. I have trained more than 600 resources on DevOps and Kubernetes, including some corporate trainings and customized boot camps. I'm an avid open source contributor and a public speaker for many events, including DevOpsCon Singapore and Data on Kubernetes and some boot camps for worldwide professionals. So these are some of the certifications that I hold. I am a solutions architect associate in AWS and Oracle Cloud. I am a CKA and a CKAD and OpenShift container certification as well. These are my pluralsight skills expert. I am an expert in DevOps Foundation, managing Docker, Kubernetes, and Terraform, using Kubernetes as a developer and microservices architecture. So before going to the topic, let's first try to understand what Kubernetes is. As most of you might have heard that it is a open source system for automating deployment, scaling, and management of containerized applications. So the key point over here is this part, containerized applications. So what actually are applications and how do we containerize them and how do we run them on Kubernetes? Let's first try to understand the types of applications. So majorly, all the applications can be divided into majorly three types. First are the business applications, databases, and platform applications. So what are actually business applications? The business applications actually contain the logic of your business, the business logic for your application. So they do not save any data. In terms, I what I mean to say is that they do not persist the data in itself. Rather, they use databases or other applications to persist the data. These are normally the front end applications, the back end APIs, and those things. So and in such applications for load balancing and for high availability, what we normally do is we use horizontal scaling. So for example, if I have load on my application at the moment, what I can do is I can scale up to 6 replicas. So I will have total 6 replicas of my application running, and any of them can serve the traffic, and the load would be balanced between them and high availability would be achieved. So for example, that this application even goes down, there would still be 5 replicas that can serve the traffic, and all replicas are alike. So if the call goes to this application or this replica, it does not matter in that sense. Then comes the databases or stateful applications. So these applications actually persist data in them. So for example, a MySQL, a Postgres, or NoSQL, or any other databases, so they actually persist data. If that data is lost, some critical information about your apps can be lost. So in such scenarios, what we do is we do vertical scaling. So in terms of load, when there is load on your database, what you can do is you can increase the size of your DB instance. So for example, increase the RAM, CPU, or storage, or whatever is actually choking. And for high availability of such applications, we do clustering. So what actually clustering means is that we create a primary and secondary cluster, replica cluster of your database. So for example, this primary is able to do the read and write operations on this primary, and then this will be actually replicating all the data on the secondary instances. So all the data is being fed into this, and then this is replicating as in intervals. And if the primary goes down, then one of the secondary will actually become primary. So that is how you achieve high availability for your databases. And the third is platform applications. So how you can define the platform applications is basically these are just helpful applications that help for the platform operations. For example, the platform observability, platform automation, and other things, or platform networking as such. So in a distributed architecture where you have multiple nodes, for example, this is one node, this is second node, and similarly you have, let's say, tens of nodes of cluster. In that sense, you would be needing a distributed monitoring or distributed logging architecture. So you would have to run your application on all the nodes. Your logging aggregator, for example, Fluentd is one of them that aggregates or that collects the logs. So you need Fluentd running on all the nodes to collect the logs from all the nodes and then send to a central uh, application and central place where you can actually then visualize the data. So in these applications, the replica needs to run on all the nodes. So these are majorly three types of applications. Now coming to containers, so a brief intro of containers. What it containers terminology actually means is that you can ship any tool that you want or anything that you want. For example, if you need to ship a car on an oil barrel, a box, anything, you can just package them into a container and then ship that container wherever you want. So similarly, when it comes to containers software terminology, so in the same manner, the application can be a front-end application, a back-end application, a platform application, database, queues, anything. You can just containerize them and then ship that container to wherever you want. That can be your dev cluster, your staging cluster, your a Kubernetes cluster, a Docker Swarm, a Docker Compose, or anything that you want to run. So that is how a container would actually work. And this is the architecture for a container. So this is the physical infrastructure. Then you have a host operating system, and then there would be the container runtime that can be Docker, that can be other tools as well. And then there is your container, which actually comes with all the binaries and libraries packaged into it, and then your actual app. So now coming to Kubernetes. So what Kubernetes does is, so if we have our application code and we have containerized it, then why do we need Kubernetes to actually run that application? So Kubernetes is just a container orchestrator. It manages containers. It manages containers in a productionized way. So it fixes issues such as scaling, networking, clustering, etc., which containers normally don't solve. So having a container in your production environment is not that easy if you are not using an orchestrator like Kubernetes or any other tool for that matter. So if you need to deploy a container in Kubernetes, the smallest deployable unit is pod. So you might have heard of it as well, but if you need to deploy your application in Kubernetes, you have to define a pod, and then you have to define the containers inside that pod. So it is the Kubernetes way of provisioning containers. So Kubernetes provides this resource, which they named as pod, to deploy containers. It can have one or more containers in it as well. So you can have multi-container pod as well. So again, in a Kubernetes cluster, so obviously it would be a distributed architecture. You will have multiple worker nodes running. So you will have your physical infrastructure, host operating system, and the container runtime. Obviously, those are the requirements of running a container. And then on top of that, you will have a kubelet. So kubelet is actually the tool responsible for communicating with the API server and actually uh, basically communicating with the API server and taking all the load from it and then shifting the pods terminology into actual containers. So, and this is your pod definition, and then you can have multiple containers running inside that pod as well. And this is how you run containers in a Docker environment. So Docker run, and this you write your whole command. And this is how you define a pod in Kubernetes. So you can see that we are defining containers as well, but when it comes to Kubernetes, we will have to define a kind pod to deploy on the Kubernetes cluster. So now, as we mentioned, that Kubernetes provides us with resources to run containers in a productionized way, in a very better way, so that you can have auto scaling, you can have other such features to help with your application, so that your application does not get any downtime or anything. So in that terms, Kubernetes also gives us a controller concept, a controller tool, you can say. So controller, what is a controller? In simple terms, a controller is just a loop. You can understand it in that term. It's just a while loop that always try to sync the current state with the desired state. So the only objective of controller is to sync the current state with the desired state. And if it's not the same, it will ask the Kubernetes API server to do something to fix this. So this is how a controller works. And once it's the current state and desired state are equal, then obviously it will become happy and will try to keep it into that position, into the sync state. So there are multiple controllers in Kubernetes: replica set, deployment, stateful sets, daemon sets, others as well. But these four are the major ones to deploy your applications on Kubernetes in, and we would be discussing these shortly. So replica set, uh, now, as we mentioned, if you want to scale your application, if you want multiple replicas of your application, of your pod, so replica set controllers handles that. So for example, I have a backend API and I want 3 replicas of it running at all times. I know that there would be load on my application, so I want 3 replicas of it be running at all times. So what I can do is I can define a replica set, which is actually a controller which will try to sync the number of replicas to the pods. It manages the pods and their replicas, and the replicas are the exact same copies. So for example, if I show you over here, at the start, when I deploy the replica set, my desired state is 3 replicas, whereas the current state is 0 replicas. It will create one, ask the API server to create a pod, then another pod, then another pod. And once the 3 pods are running of my application, so now it will become happy that, okay, 3 desired is also 3 and current is also 3. So the loop actually that passes now. But a shortcoming of replica set is that versioning is not handled. So for example, a v1.0 version of my application is running, but now I want a v2.0 version of my application, a newer version, a new features I have introduced. So replica set would not be able to handle that. So in that terms, we need another controller, which is deployments. So the controller that is actually deployed for the business apps, or mostly used for the business applications, is deployments, which actually creates replica sets, and replica sets then actually creates the pods. So deployment provides rolling update and rollback feature as well. And so for example, the desired is that I want to update my application to 2.0 version, and the current state is that the application is running with 1.0 version. So what will happen is that deployment will create a new replica set with app 2.0 image and downscale the previous replica set as the new replica set is getting up. So that is how it will work. It is called as rolling update. The newer version will start getting up and previous version will start scaling down. So that is how it will work. And when it will be updated, then obviously it will become happy that, okay, now the current and desired states are in sync. But somehow, if you need persistence for your application, so even though I told you earlier that business apps don't need persistence normally, but somehow, let's say if you need persistence, so this is how it will work. The deployment will create a replica set will create a pod, and pod will actually have a PVC where it will be persisting data. So PVC is a way of persisting data in Kubernetes. I would not be going into much detail for that, but yeah, that is how a pod actually persists data in Kubernetes. But the issue is that when you scale your deployment to, let's say, 3 replicas, the issue is all 3 of them will be using the same PVC. The issue would be that, for example, both of these pods write the same data at the same time. Then data corruption can occur, data inconsistency can occur, because as all 3 of them are sharing the same persistence, same thing. So if this is also updating, this is also updating, then there might be that in a fraction of a second, data inconsistency can occur over there. So that is why deployments are not the ideal controller when it comes to applications that need to persist data. The other controller is daemon set. Daemon set is almost similar to replica set as we discussed earlier, but the only difference is that all the replicas now run on each node. So for example, I have a 10 node Kubernetes cluster. So there will be each pod, each replica, there will be 10 replicas, and each replica would be running on each node. So that's how it works. So as we mentioned earlier, for the platform applications, so daemon set is actually the best resource for platform applications, because we need it to run on all the nodes, the logging exporters, the monitoring exporters, and those things. And that's how the deploy daemon set controller will work. So desired would be to run all run a replica on all the nodes of the cluster, whereas current would be that there would be 0 replicas. So it will run a pod per node on all the nodes of the cluster. So that's how daemon set controller works. And if you need somehow persistence, so it will work again in the same way as deployments, that all of them would be sharing the same PVC. So again, for persistence workloads, daemon sets again is not an ideal controller for you. Now coming to the stateful sets controller, which by the word or by the terminology, you can think that this is for stateful applications, the databases and stateful apps that we discussed earlier. So if you need to run an application or which needs persistence, stateful sets is the best tool for that. It guarantees the ordering and uniqueness of pods by having incremental naming conventions. So we will see about it, that what does it actually mean, the uniqueness of naming and the incremental naming. But in this scenario, the replica pods are not interchangeable. How it's not interchangeable? Because over here, if you see that there are multiple replicas of my stateful set now, and each pod has its own PVC. So counter 0 has its own PVC, counter 1 has its own, counter 2 has its own. So now if the call goes to counter 0, it's not the same as going to counter 1, because it has its own data, and counter 1 has its own data to work on. So if the call is going to counter 0, it will be showing some other data, whereas counter 1 would be showing some other data. And also the incremental naming. So for example, now you can see that over here, the naming would be incremental, 0, 1, 2, 3. If 0 goes down, the new pod that will come up will again have the 0 naming, 0 name in it. So deployments versus stateful sets, if we use deployments for databases, so for example, as we discussed earlier, for example, if we use the deployment controller for databases, data consistency can be compromised, as we have discussed it already, that both of the pods would be sharing the same PVC and would be changing the same PVC data. So data consistency can be compromised. And also high availability cannot be achieved, because if the PVC gets deleted, 3 pods are using the same PVC. If the PVC gets deleted, all the 3 pods would also go down, because that they were sharing that PVC. Now coming to why stateful sets is the ideal for databases, because as I mentioned, in databases, normally we do clustering for high availability. So this is a Postgres cluster. This is the primary replica. These two are secondary replicas. And you can see that stateful sets provide you with that feature, that each of it will have its own PVC. So they all have their own PVCs. Data is being written on this replica and then being synced with these replicas. If the primary goes down for some reason, for any of the reasons, the primary goes down, the PVC goes down, or anything, any of the secondary will become the primary one, and the meanwhile the first one will automatically get back up. So that's how beneficial a stateful set is in terms of database clustering. So why stateful sets would these databases form clusters to provide high availability, and again, each individual pod should have unique identity, and they should be able to predict other pod names as well. So over here, when we say about clustering, so this pod should be able to predict other pod names, because it would be syncing the data with them. So that's why again, stateful set helps in that. PVC doesn't delete automatically, even if pods or stateful set delete. So again, that's a benefit of using stateful sets for it. And yeah, I believe that's it in the terms of differences between deployments, stateful sets, and daemon sets when it comes to persistence or in Kubernetes. So if you guys have any questions, you can connect with me on LinkedIn or my GitHub and can ask there, and I will be happy to answer them. So yeah, that's it from my side. Thank you, everyone.